at question 2. So again, this is another vector question. So let's have a look. So a particle P moves with constant acceleration. So every time is constant acceleration, let's definitely have something to do with SUVAT. And then is 2I minus 3J. So let me just write it here. So acceleration equal to 2 and then -3 meters per second squared. And at time t equal to 0, the particle is at the point A and is moving with velocity -I plus 4j. So if we let point A to be our starting point, that means u is equal to -1 and then 4 meter per second. And at time t is equal to capital T seconds, P is moving in the direction of vector 3I minus 4j. So every time when they talk about the direction of motion, that has to do something with the velocity. Yeah. So that means we need the velocity vector at time t equal to capital T seconds. And then we want to find the value of t. So what we need is the velocity at time t, and then we let it to be the endpoint. So that's what we're looking for. Yeah. And then we're looking for what is the time at that point. Yeah. So we know A, we know U, and we need to use T, and we want to work out velocity, final velocity. So we need to use V equal to U plus AT. So V equal to U, which is -1, 4, and then plus A, which is 2, -3, and then times T, which is capital T. So we can write this as -1 plus 2T, and then 4 minus 3T. And then, so because it's in the direction of vector 3I minus 4j, so that means this vector has to be parallel to 3 and then -4. Yeah. So we know if two vectors are parallel to each other, so that means that definitely have a scale factor between them. Yeah. And then that scale factor has to be the same for both the I component and j component. So to work out that scale factor, we can use -1 plus 2t divided by 3. So that would be the scale factor from the I component. And if we use 4 minus 3t divided by -4, then that will be the scale factor for the j component. And then because those two vectors are parallel, so the scale factor has to be the same, so they will be equal to each other. Then we just have to solve this to work out the value of t. So cross multiply -1 times by -4 is +4, and then 2t times -4 is -8t. And that's equal to, so 3 times by 4, 12, minus 3 times -3t would be -90. And then we can plus 90 for both sides. So -8t plus 90 will be t. And then -4 for both sides. We have t equal to 8 seconds. Then that'll be the answer for part A. And then let's have a look at part B. So find at time t equal to 4 seconds, P is at the point B, and we want to find the distance of AB. So if we're looking for the distance of AB, so first we need to find out the displacement of AB. So once we find the displacement of AB, and then distance is just the magnitude of the displacement vector. So once we find the displacement of AB, we can just take the magnitude of that vector, and then we get the answer. Yeah. So as AB is what we're looking for. And the things we're looking for the displacement of AB. So A will be our starting point. So that means U is equal to -1, 4, like before. Yeah. And then acceleration is 2 and then -3. So A is equal to 2 and -3. And then we know T is equal to 4 seconds. And we don't know the velocity at point B. So we know S, we know U, we know A, we know T. We can just use S equal to UT plus half AT squared. So u is -1, 4, and then t is 4, plus half times by acceleration, which is 2, -3, and times by t squared, which is 4 squared. So simplify that. So so then this will be -4/16, and then plus. So half times by 4 squared is 8. So 2 times 8 is 16. -3 times 8 is -24. So plus -4 plus 16, 12. And then 16 plus -24 is 16 minus 24. So -8. And that will be our displacement vector. So then the distance of AB, just the magnitude of that. So that'd be square root of 12 square plus -8 square. So that is equal to, put in the calculator, that's 4 root 13 meters. Then that'll be our final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.